Welcome to this afternoon session. I hope that we can keep you excited still, even though it's afternoon. My name is Ninoslav, and I'm here with James Petteri, my colleague from security team. And we're going to talk about ESQL, how it's going to help us transform data investigation. I'm super excited to be here and talk about ESQL. It's been a long journey that has been enabled by our amazing engineers in Elastic across the whole company. So the journey is just getting started. We're super excited about it. Before we start off, can you raise your hand? How many are using Elastic today? Oh, it's half of you. So I hope that you will see the benefit of ESQL, and the rest of you hope that we can inspire you to go out and try it out. We have a public demo site. You can go and play, or you can set up a cloud account. So if we start by saying one of the challenges we have today is that we have a mountain illustrated up here of unstructured data coming in. I think the statistics say that 90% of data is unstructured, and we also have a lot of customers that are ingesting data that is in all kind of formats. We want to enable our users to sift through these data types, logs, metrics, you name it, events, in a much better way than they are today. We are having a very powerful UI-driven workflows in Kibana and Elastic today to access this data. However, we know that we are onboarding a lot of users that are accustomed to more expression-driven workflows, and also are accustomed to our pipe query languages. So that's why we are investing in ESQL. Sorry about that. Before we dive in ESQL, I'd like to talk to you about some of the challenges that we have today. We have a challenge of when users are accessing the data, they need to go to several places. There's several methods to use to be able to enable, get hold of the logs, get hold of the metrics. And sorry about that. That was throat, yeah. So our user base has grown over time from application developers to SREs to threat hunters, and the same has their data types. This has evolved Elastic to actually develop several query languages to access the data, and sort of to also to organize your data via schema files and transforms and so on. And we are really focusing on shorten the time to insight and shorten the time to, means to resolution. And that's why we want to shorten the time to insight for our users by enabling them. So what I want you to do is imagine having everything in one place. You can search, you can calculate, you can transform, you can filter, you can aggregate, and visualize all from one screen. And then imagine a next generation search engine that are capable of faster search while delivering a comprehensive language for data investigation and exploration. And the last part is imagine a way for every individual to access data, explore it, and visualizing it. So introducing ESQL, turning your data into gold. When I talk about ESQL, I see it as three things, kind of like a Kinder Surprise. First thing is we have a very, very powerful query engine that improves efficiency and delivers query speed. With ESQL query engine, searches, aggregations are executed in multiple stages concurrently for greater speed and efficiency. Second of all, we have a new pipe query language that makes it easier to transform your data, simplify the data investigation, and unlocks insights for your business value. It enables companies to be able to do aggregations at the same time as they're doing visualization in one. One example could be that you have some flat log messages that you are grogging or parsing on, and then doing aggregation on top of it. James will later on demo how that look like and how it's going to help our users shorten the time to insight by doing several things at once. And the third Kinder Surprise is unified query experience. So this will be enabled in Kibana across Kibana, both in security and observability, and you will be able to query, aggregate, and visualize your data all in one place. So search, rules, alerts, you name it, ESQL will be the way you define and search your data. The first is a distributed query engine. So we are launching, as I mentioned before, a new distributed and dedicated query engine where its purpose is to help our users expedite data handling, allowing for quicker and more responsive analysis. The endpoint is _query, and there is no transpilation or translation like we have today. So it's directly to _query. The queries are parsed and optimized for distributed execution, and it operates in blocks instead of one row at a time. It takes advantage of specialization and multi-threading, and the benchmarks are actually showing that ESQL is outperforming DSL in many instances. We have a public dashboard on ESQL performance that you can follow our journey on how is it progressing. There is a link in the dashboard so you can access to it when you get the presentation, and it shows that it is faster than our current aggregations, in some cases even without many optimizations. What the chart shows here is a query that is on a New York taxis, where we have a simple aggregations or the total amount, average total amount grouped by passenger count, and then we are sorting by the passenger count. The pink line there is multi-threaded ESQL. The blue one is single-threaded, and then we have the green line, which is our current _search. The lower, the better. That's in milliseconds that we have. It's quite impressive. The second is, of course, the language itself. When you write a ESQL query, you start off with some source commands. So it's a series of commands that are chained together with pipes. A source command retrieves and generates data in form of a table. So if you take a from command, it will generate a table and you retrieve it from Elasticsearch, illustrated by the icon here. And you will take that table and actually use some processing commands. So a table as an input produces by the previous source command and produces a table as an output. Example, you use eval. You can use eval for that. You can change the processing commands separated by a pipe character, and each process command works on the output of the previous command. I just set up a table, some of the processing commands that we have in ESQL already today. Enrich is a lookup, and I think James will also demo that later, where you can actually enrich your data set utilizing a lookup. Eval is also, of course, transforming your data in the way you wish. ESQL has a comprehensive set of functions and operators for working with data. So far, we have these categories, where the most popular is, of course, the aggregating function that can be used together with stats command. But otherwise, we have like the date format, and there is a very comprehensive documentation. You can go in and look at it to see what are you capable of doing with the ESQL query language, and does it fit your needs. So how does an ESQL query look like? If we take this example, for instance, then we have both the query and the result represented. On the right, you see the query that selects data from Apache logs. then filters for log entry related to the logging page, and then buckets these entries in the specific time intervals. Counts the number of logins for each user in those time intervals, and then outputs the result sorted by the highest number of login attempts. This produces both a tabular form of the results and also visual representation. We'll showcase that later as well. But ESQL is expressive, powerful, composable, extendable, and fast. The third Kinder surprise is the unified user experience and how a user is going to interact with ESQL. So ESQL enables users to do data exploration, data visualization, all in one, and data transformation. What we're showcasing here is Discover. We actually have the query, and you are having the visual representation and tabular format. We are saying like ESQL doesn't just show data, it brings them to life. It will not only be available in Discover, it will be available in Security Timeline. You can do alerts with ESQL as well, and it will be accessible through the AI Assistant. So we have an AI Assistant that can help you out on writing your ESQL queries in particular use case. So you can ask them questions and how can I investigate these data types. That is a really, really cool feature, especially if you're new to pipe query language. You can get a lot of help there as well because we are feeding it with comprehensive documentation. So when we start building ESQL, we had a set of a private beta program where we have a lot of customers contributing to it to us and actually coming in with some inputs, and we talked to a lot of users. One of them was Informatica. So Informatica is a company that is specialized in data management and integration. It's an enterprise cloud data management leader, and they provide software and services to help organizations organize, process, and make sense of their data. This includes tasks like data integration, data quality, data governance, and so on. And they actually have a booth here at AWS re:Invent. So if that's something you need, you can actually go ahead and visit. They are using Elastic across the board. So Informatica has both observability use cases and security, and they're utilizing AI and ML to shorten the time to insights and resolve incidents faster on top of that. They're also utilizing Elastic's powerful CM offering to accelerate fixing security issues before they become a problem. That's why the quote is here, is they have 8.5 billion events per day that they're utilizing a platform to simply sift through and investigate the different security threats they're having. And to give you some statistics about Informatica's usage of Elastic. So they have more than 60,000 shards and are ingesting 37 terabytes per day, 200 plus data nodes, to just mention a few of them. So we asked them, some of the users, and this was one of the quotes that they came back with. ESQL is going to change everything, and we have been looking forward to it for many years. Once released, it will be our primary query expression language. And when they saw the ability to be able to aggregate, filter, do lookups, it's a huge time saver. So yeah, they're looking very much forward to it. One of the examples that we talked about, how will they actually use ESQL? So they will use it to aggregate, transform, calculate, and search metrics, logs, and traces, pinpointing performance bottlenecks and system issues, reducing time to resolution by removing the hassle of navigating multiple screens, and then also, of course, build observability and security alerts with aggregated values as a threshold. So on the right here, we're seeing how ESQL alerting feature is working, where you actually can utilize the language and set up an alert rule type. Second thing that we'll talk about is, of course, the visualization of it. So DevOps teams are constantly in a race against time, deploying multiple updates, patches, and new features. So visualizing performance bottlenecks and system issues with ESQL charts is super important for them and can help them a lot. I'll pass it over to James, who's going to do a demo. Thanks.
Okay. Good afternoon, everyone. Let me just switch here. Awesome. Thanks for sticking around for the afternoon session. I know it's been a long day. So I'm going to give you quite a few different demos. I'm going to start with the security one because I am a security guy. I'm on a product management team for security, talking about how we can pivot from detections to threat hunting to back to detections and do all of that really cool stuff with ESQL. I have a bunch of other demos as well, but I think this one will really resonate, especially if you are a security user in the room. If you're not, it will also resonate because ESQL is pretty awesome. All right, so right now we're in our alerts view within Elasticsearch. This is basically the page where if something bad is happening in a user's environment, they get alerted on it based off of our rules that we provide or any custom rules that they've written. Over here, I'm looking at a rule where it said, hey, you have a potentially malicious hostname that has been queried via DNS, right? And I can see here basically all the details. Hopefully you can see that on the screen. But there's a DNS question name of cdnverify.net over here, right? So typically, the workflow of someone looking at these alerts would be, OK, let me look into this successful DNS lookup and get some information about, for example, the resolved IP address, so on and so forth. So what we're going to do is we're going to pivot to our timeline view. And I'll talk about the experience of what existed before ESQL, and then how ESQL will complement that existing behavior. So within the timeline, a user can do several different queries. One of them is like a very basic KQL query. So what I've done here is I've filtered using KQL syntax really simply. Hey, we're going to look for event types where there was a DNS lookup result and that outcome was successful, and specifically for the DNS question name, which is cdnverify.net. And we have quite a few results here. Okay. So we can see here cdnverify.net. If I look deeper into the actual event, one thing I'd like to know is, hey, listen, what did this name resolve to from a DNS perspective? Now, because of the way we collect these logs, which is an event type on Windows called event tracing for Windows, where we get DNS events, they don't actually give us the field in a nice format. It's actually part of the message field here, where they say, hey, your DNS query is completed. It was actually resolved to this IP address that you can see there. But it's not parsed out as part of the default data set. But that's important to me. I'd love to be able to use that IP field to do some further investigation, so on and so forth. So prior to ESQL, being able to work with something that's unparsed like this was a real pain. If you're used to Elastic, if you asked Elastic how you would deal with this, our primary response would be, oh, create an ingest pipeline and reindex or something like that, which was never a great answer to give you. So now with ESQL, we can tell you, do it as part of the query. So I'm going to pivot to my ESQL tab here. You can see it's part of the same experience, right? I haven't left my security solution area. I'm still, as an analyst, focused where I know where to be. And what we're going to do is we're going to build this query together. So ESQL, as Niroslav was saying, we start off by declaring, hey, this is the index or indices that I want to query. Whereas previously with something like KQL, you would select it from the drop-down picker. It's now part of the query itself. So we're going to look at those endpoint events, specifically the network events. OK, great. That's the first line. Let's do some basic filtering. Let's apply the same filters that we had before in KQL. So we have our first pipe. And you can see the where action there. I should say the where command, where we're going to filter. Pretty straightforward, nothing too different so far. I'm going to run it like this, just so you can see sort of what we get. And we get results like you would expect in previous experiences with KQL, nothing too different. But here's where it's different. So let's parse out that IP address from the message field. So we're going to use our dissect command. Dissect is something we've had available in Logstash and ingest pipelines for a while. We've brought it into ESQL. The same syntax you're used to. So it's not different. Dissect works in the exact same way. So we're going to parse it out into a new field called dns.resolvedIP. Really, really simply, this is basically saying the way dissect works is just follow this pattern, and when you find a match, extract it out. So why don't we go ahead and do that? And now it's extracted out. You'll notice as well that we're not really waiting. You saw how quick that was? Even though we're doing like inline parsing over the last 7 days worth of DNS events, we didn't have to wait at all, which is something Niroslav was alluding to. We built this for speed and scale. Let's do some additional filtering. We're only interested in events where that new field we just parsed out is not null. Let's limit it to the top 1,000 results. And then let's only keep the fields we're interested in, right? Like we're returning quite a few fields here, depending on what we have in that data set. Let's only keep the fields relevant for me as a security analyst as I'm doing my investigation. And voila, we have our results there. Really, really easy to get information that was previously inaccessible before. And like I was saying, we didn't even have to wait. It was just all there readily available for me. Now, of course, we can do more with it, right? Like we know we had 167 attempts of cdnverify.net that resolved to this IP address. Why don't we go ahead now and start using some of the charting capabilities of ESQL to give me a better picture? Seeing 167 hits like this as a security analyst doesn't help me too much. But when we chart it out, it gets even better. So I have a similar query here where we have the same filters to start. But I'm going to create some new fields using our date functions to do some bucketing. And then I'm also going to do some aggregations. So what we're going to do is we're going to create a new field called DNS count, which is going to count all the records. And we're going to split them by the previous field we just created, date, which is going to bucket into 1 day timestamps, the host name, and the DNS question. Do some limiting, and then again, keep the same results, the fields we're interested in. And what this gives us now is this chart. And you'll notice, as part of my query, I didn't have to declare a chart. What we're doing is we're automatically suggesting charts depending on the output of the data returned. And this is saying, listen, for the type of data you're returning, here's the charts which make most sense. And what's interesting, now I can see this chart just by looking at it. We have these DNS events more or less around 48 requests per day, which is, because they're the same from a security analyst persona perspective, it indicates persistence. So what we now know is, hey, you've had this threat making these requests to this DNS name very persistently, 48 per day, that's 2 per hour, very typical for like C2 communication, really, really powerful stuff. And again, we didn't have to leave our search area. Prior to this, you'd have to go into our Visualize tab, create a visualization, so on and so forth. What's even nicer is we've given you editing capability right within here as well. So if you wanted to change any of this, change the color scheme, whatever you want to do, you can. And you can also save it to a dashboard right within here. And you can create a new dashboard right within here. So as Nino Staff was saying, 6 different areas or so where you had to pivot before, you are now working in one zone, thanks to the power of ESQL. But we're still only scratching the surface here. These were pretty simplistic queries, to be honest. Let's dive a bit deeper. So I have another query here. This is pretty significant. It's 18 lines. And what this query is attempting to do is, I put this together specifically to highlight how much you can do now within the query bar, which would have typically taken 7, 8, or even 9 steps and different areas of the Elastic Stack to do. So this query, what this is looking for, I had a use case as a security analyst where, listen, I want to be able to find out if there are users, real users, so human beings, not service accounts, not any other account which isn't a human, attempting to transfer data outside of my network, greater than 1 gigabyte within size, from multiple different hosts on a given day. Pretty standard use case for security. Prior to this, it was not easy to do. You could do it, it was just really convoluted ways of doing it. So what this query is doing, I'll walk you through it line by line, and hopefully it gives you an idea of some of the functions that we've added here to make your lives easier. So again, some basic filtering. You can see here we're doing like CIDR notation to filter out internal traffic. Again, we're only interested in data leaving our organization. And we're also looking specifically for traffic that has an assigned autonomous system name. This is something we add to our data, so we're just making sure that's part of it. We're doing some date mat again. More than date mat, we're just basically bucketing and creating, again, we want it per day. So we're going to say, hey, let's truncate the timestamp to a day, and then we want it formatted in a human readable value rather than something which is difficult for a human to read. And this is one of my favorite parts, where we're doing 3 aggregations at once in one line, really, really simply. If you've ever used Query DSL or anything else to do this, you know this would have been a really long blob of JSON. Now it's one line. So we're doing an aggregation to count all the traffic. We're going to do a unique count of the hosts, because remember, more than one host we want to see this traffic coming out of. We're going to sum up the source bytes, because we're interested in seeing if it was 1 gigabyte or less. And then we're going to split it by the user, the process which made the request, the day on which it happened, and also that autonomous system name. The next line is also one of my favorites, where we're going to use our enrich command. Enrich is allowing us to do what you typically do in an ingest pipeline with the enrich command, but now as part of the query. If any of you are familiar with other languages, some of them call this a lookup. We named it enrich just to align it with what we do in the ingest side, but now you can do it in line. So what we're going to do with this enrich command is we're going to grab that user, and we're going to check it against a list of users that we have to see what group they belong to, LDAP group or whatever. Remember, we're interested in real users here, so we're going to filter out anything which is not a real user. And we're going to use the enrich command to do this. So you can see here, after I do that, and then we're going to say, OK, let's make sure we have a username and a group name. Let's grab that total bytes value and transform it from bytes to gigabytes. So some very simple math there, and also some rounding. Let's make sure we're not showing results which are 0 gigabytes. And then we're using a special format of the eval command to create a case statement. So basically, we're doing like a conditional check. Say, listen, if the total gigabytes are greater than 1 and the unique host count is greater or equal to 2, then create a new field called follow-up and assign a value of true if it matches or false if it doesn't. As a security analyst, what this allows me to do is get an immediate field that gives me a reaction to say, OK, I need to follow up on this incident or not. We're going to filter specifically for those follow-up events where true. And again, we're not going to show where we have groups, I should say users within the group of system users. We're going to limit to the top 10 results. We're going to sort by total gigabytes descending. And then we're going to keep the fields of interest. And the result here is this. There was this one person, James Spiteri, I don't know who that is. It seems like from Chrome, they exfiltrated over 4 gigabytes of data from 2 unique hosts, sending it to Google. It was funny, when I was simulating this behavior, I just launched up Google Drive and started chucking random files into it. Hopefully that was OK for our InfoSec team, but we'll see. And you can see here it's for this specific day, right? So we're bucketing it per day. And again, I just want to highlight, this 18 lines of ESQL query would have taken a lot of effort to do outside of ESQL. Now, of course, a search is great. What's even better is if I can just get alerted on it, right? So within the security solution, we added the ability to create detection rules based off of ESQL. This is pretty much the same example I was showing in an alert format here. So you can see the same or very similar query definition. I just dropped it down to 500 megabytes instead of a gigabyte. But you can now create these detections as if you were creating anything else. This is really powerful for a security user now because we've given them full control over the output of the query. Whereas before, the query types you had, they weren't that flexible in terms of what you wanted to output. You can now have full control over that. And just to show you, if I go into edit rule settings here, you can see there's a new rule type for ESQL. And pretty much you can have the same query that we saw before when it came to the timeline. So that's some of our security use cases. Of course, it's not just available within security. I thought I'd start out with that because, again, I'm a security guy and I like talking about security as much as I can. But let's pivot to something like Discover. So this is a pretty interesting use case. What I wanted to calculate, let's say from an observability perspective now, we're bringing in, of course, day-to-day, a bunch of different log types, right? And it's very normal for all of us as we're bringing in different logs. We have various different ingest pipelines. We have logs coming in from different locations. So sometimes there's a bit of a latency, right, from when the actual event was created to when it was actually ingested into Elasticsearch. But one of our goals should be to try and reduce that ingest latency as much as possible. The way to start that is identifying which data sources have a particularly high ingest latency. So I'm doing quite a bit of work with some date math here, converting it into a double format to do some like millisecond extractions and stuff like that. You can see this auto bucket function, which is really cool. So you can basically say, hey, take this timestamp. I want 24 buckets between this date range and that date range. And you'll also notice functions like the now function, which is really handy. And you can also do things like now minus 1 day. So very human readable, very, very easy. And this is the result we get. So you can see here, this is all, we have several different data sources here. But our AWS VPC flow logs are taking the longest to ingest for whatever reason, taking an average of 197 seconds. which is not good, right? We should probably reduce that. Everything else is pretty low. So 26 seconds, 19, 11, 8, right? So this query, just really quickly, working with some date math, using the different timestamps available within the documents themselves, allowed me to just identify straight away our VPC flow logs take the longest to ingest. What can we do about that going forward? Now, of course, Neoslav stored this as well, but right from Discover, if we wanted to alert on this, we can. So we can create a threshold rule. It will populate the query straight from the query bar, and then we can create an alert really, really easily. And you can see then we have all the other action types, depending on what you want to do to follow up. Really, really powerful stuff. However, that's not only what we can do. So ESQL itself, as Neoslav was explaining, it has its own new API endpoint, right? So because we created a new query engine, we didn't put it under the same _search endpoint. We created a brand new one. And this is what it looks like. So first, what I'll do is show you different ways you can run it right within DevTools. So you can see here, I'll show two different variants. So you can see we're posting to the _query endpoint. And if I want to really simply, I can just put in the ESQL query instead. So imagine doing this with query DSL. You know how many lines of JSON that would be? So you can even reduce, like if you're calling this from your applications or wherever you're calling it from programmatically, you can really, really reduce the size of that. And I'll just run this here, and I'll also use this opportunity to show some things we've done to help diagnose. So this is an expensive query. And one of the reasons I'm actually showing this is to show what we've done from like a task manager perspective. So you can see here, it's really easy to identify if you have long-running queries now. So we put the query right in there. You can see how long it's taken, if you want to cancel it, perhaps. But traditionally, with queries, this was not easy. Yes, everything made it into the task manager, but identifying which query is causing these delayed tasks was typically not the easiest thing to do. So we wanted to make sure with ESQL, we made this easier. Also, from an Elasticsearch logging perspective, we actually log every single query invocation, and we tell you how long it took. So we try to add as many options as possible to diagnose any issues you're having with ESQL. And you can see here the query finished now. By default, the JSON response is going to return columns and values. However, if you wanted something a bit better, we do support things like text format and CSV and a bunch of others. I'll use that opportunity to show you also that if you wanted to, you can combine ESQL with query DSL filters. So that's what I'm doing here. Instead of doing the date range filtering as part of the SQL query, I'm just doing it in the traditional query DSL way. Some people would want that. That's totally fine. And I'll also use the output, the text output for this one as an example. So just to highlight some of the things we've done, we know many of you will use this programmatically rather than through Kibana or otherwise. We just really wanted to make sure you're aware that, listen, if you wanted to start thinking about any existing applications you have, which are querying Elasticsearch with some convoluted long query DSL, you can now start to think about, hey, let's convert some of these to SQL queries. And here you go. This is the text format of those same results, but easier to digest. However you're using them programmatically, you do have that option available, and there's more. So within our docs, we list out all the different types of outputs you can get from the query endpoint. One more thing I wanted to show you, which is, Neoslav mentioned, we made our assistants aware of ESQL. If you haven't been following, Elastic has been doing a lot of work in the generative AI space. And one of the things we did was create AI assistants, which basically integrate with large language models to help with anything from dealing with security threats to query generation. Now, of course, there was no large language model that was aware of ESQL because we were developing it. There was no public knowledge about it. They couldn't suck up anything to learn on that. So we had to create this whole concept of a knowledge base to be able to ask questions about the ESQL and get results back. So here I have a long-running thread with our assistant about crafting ESQL queries. This is really, really helpful. This is a brand new language. Instead of sifting through all the documentation, even though we've made it easy and we provide actually something I should probably show, if I just go back to Discover, we do provide like an inline guide for ESQL as well, which is very, very helpful. But still, sometimes I just have like a natural language use case where I want a query for. I don't want to mess around with all the different commands. And that's where the assistant really comes in. And this is true for both our security assistant as well as observability. We've both done the work here for this. So within my long-running thread, I just use this as different examples to show how powerful it is. But the first example I have is literally, I'm asking the assistant, hopefully it shows on the screen, I want to detect brute force attempts against Azure AD. Give me an ESQL query to do that. And it spits out a perfectly valid, semantically correct ESQL query, and it explains it to me. How cool is that, right? And you can see, so you can be really vague, but you can also be really descriptive. So you can say, hey, listen, I have this particular index. I want to use these fields to do X, Y, and Z. Give me the query to do it, and it will do it. One of the features I really like for using the assistant for this is, sometimes you create queries, but I don't want to go through the hassle of commenting them out for my colleagues, right? So I just use the assistant to do that. So I basically give it a query and say, hey, can you go in line by line and add a comment about what each line is doing? And there we go. So there's an example of that. Perfect complement to a user crafting these queries. And now I have a fully commented query, which I didn't have to spend the time to do myself. I just used the assistant to do it. That's what I want to demo for you today. If you did want to see more detail in terms of demos, do stop by our booth. We're at booth 880. And as Neoslav said, we also have a public demo instance, which you can use. I'm going to hand it back over to Nino now to close us out for the presentation. And then I think at the end, we'll also have a Q&A.
Thanks, James. So to recap, we have a couple of key benefits based on the ESQL engine and ESQL language and the unified experience as well. So first of all, what we're trying to accomplish is really show the time to insight. I really hope that you, by James' demo, could see that. Not only was he able to do a lot of things just in a query, but he was actually able to do it in alerts, in Discover, in security as well. And he done it with great query speed. He mentioned it shortly, but it's retrieving data much faster because it has a more powerful engine. The third one is we are really trying to reduce the friction of bringing data into Elasticsearch. So this can also be utilized as part of getting the data ingested. So what we are trying to accomplish is also post-ingest data processing, so meaning that when the data has gotten into Elasticsearch and you are querying, what we would like to enable our analysts to do is simply do the ad hoc data exploration without needing to go back to reindexing the data. So that is super powerful because teams are not working directly together and they can actually go through the process and finding whatever they need to investigate. Improving alerting, we show that as well. So by enabling the ability to aggregate the alert rule types, it's super powerful and can enable users to do much more than what they can do today. And then, of course, the new transformative search engine that we are enabling. So, yeah, this is what we have for you today in terms of ESQL. Are there any questions you would like to have, a Q&A? Maybe for me and James?